Okay, so in this video, we're going to discuss the differences between a Taylor series, which was that recipe we just found for finding the power series of a differentiable function, and what are called Maclaurin series. Well, let's just remind ourselves what a Taylor series was. A Taylor series, we're starting off with some differentiable function, and we want to find its power series representation. And the formula or recipe we have for that is basically finding all those unknown coefficients, those c sub n's, by taking derivatives and dividing by factorials. So we found that the general form of a Taylor series for a function f of x can be written like the following. We have the first term is our function evaluated at a, where we're centering our series around, followed by the first derivative evaluated at a, times x minus a to the first power, plus the second term, which is a second derivative, evaluated at a, all over 2 factorial, times x minus a squared, plus the third term, which is the third derivative, evaluated at a, all over 3 factorial, times x minus a cubed, and so on. Okay. And this was the general form of a Taylor series. And we said the Taylor series, again, was to find the power series of a function f of x. So again, all Taylor series are power series. And well, you might be wondering, what is a Maclaurin series? And a Maclaurin series, the way I want you to think about this is a Taylor series centered at a equals 0. So it's literally the same thing as a Taylor series, but the very specific case where a equals 0. So a Maclaurin series of a function f of x is the function evaluated at 0 instead of a, plus the first derivative of the function evaluated at 0 instead of a, times x to the first power, plus the second derivative of our function evaluated at 0, all over 2 factorial, times an x squared. The third term, plus the third derivative evaluated at 0, all over 3 factorial, times x cubed, and so on. So it's the same thing as a Taylor series, except in the specific case where we're centering that Taylor series at a equals 0. And one reason we might want to think about doing this is, well, usually evaluating functions at 0 and evaluating functions' derivatives at 0 and the second derivatives, third derivatives, tends to be a little easier than evaluating functions at non-zero numbers. You could think about that as some of the motivation. Check out the next video in which we start figuring out what the Taylor series, or more specifically, the Maclaurin series, for a bunch of known functions that we know, like sine, cosine, and e to the x are. Check it out.